A quick video on how to set up an IO-Link device with the SIG 350. Right now I'm just going to be using the DT80 because this is the sensor in question. And what I'm going to do is configure the DT80, show how it's mapped over to the PLC, to what register, and how do we get that information into a PLC. So right now I've got just the DT80 set up here. There are some configurations that you can change in SOPUS or over the PLC. So what we want to look at here is I am going down to a resolution of 0.1 millimeters. So that's what will be coming to my PLC. And my connection, my IO-Link process data. So a lot of different IO-Link devices, you can manipulate the process data inside of SOPUS or over IO-Link with the PLC. Right now I'm just going to use distance plus scale plus Q1. And why that is important is looking at the IODD file itself. The IODD file can be found on our website. You just go to SIG.com, type in the 7-digit part number on the back of the sensor, go to downloads and software, and then grab the IODD file. So when we look at these two, you can see here that I've got multiple selections, distance plus scale, Q1, Q2. Looking at the IODD file, we can see that responds to the same thing here. So process data 0 is just measurement value scale, like we see here. But what I've got is process data select to 1. That way that I can get the distance, the scale, Q1, 2, and Q1 and Q2. So that's how those two correlate. But we need to understand how much data we have coming into the device itself. So looking at my network, I've already got my SIG 350 configured with a consume of 148 bytes and a produce of 52. Since this is an input device, it'll be going to my consume, which will start at D13,000. So that tells us where our data is going to start inside the PLC. Now, to understand the data itself, where it's going to land, we have to look at how many bytes, the byte offset of where it's going to start. So since this device will be using a 32-bit, which is 4 bytes of data, we have 2 bytes here, and then we have a couple booleans. So we can see here byte 0, 1, 2, 3, 4, and 5. So that is a total of 6 bytes of data that will be coming over IO-Link. There's a maximum of 32 bytes of data, process data, that comes over IO-Link. So with this sensor here, we have a total of 6 bytes of data. So looking at the manual of the SIG 350, I can see that byte 0 is DI status. Byte 1 is reserved. 2 to 3 is the DI status, and then we're going to port 1, since I'll be plugging this into port 1 of the SIG 350. So first, I'll go ahead and close out of the DT80 and take it offline. Now, right now I'm not going to plug in the DT80 to the SIG 350, just so that we can see this data coming through. So this is the look from the PLC itself of what data is coming in, and I've got it down to a bit level here. So we'll just go ahead and take it back so we get the full data. So we were looking at here, I said my data started at D13,000. So 13,000, but we need to offset the bytes as well. So I need to be looking at starting at byte 6 is where my data is going to start. And our IODD file says that byte 0 is going to start with the distance. So byte 0, byte 1, 2, and 3 will all be distance, starting at byte 6 of what's coming into the PLC. So each one of these words is 2 bytes. So starting here, I know I've got to start at byte 6. So 0, 1, 2, 3, 4, 5, 6, 7. So it should be 6, 7, and 8 and 9 is where the distance data will come. Now we can see these 2 words or 4 bytes changing. Also, we saw this byte, this word, these 2 bytes right here change as well. So with IO link data, it doesn't come in order. So we need to do a byte swap and a word swap to make this usable data. So now if I bring up my ladder, and I've already got the program written here, we can see that this data is the same as what's coming in here. So D13004 is being moved here. D13003, which right now is 0, is moved here. But you can see D13003 is going to D3358, while 4, which is the next one, is going to the word before it. So what I'm doing here is I'm byte swapping it. I'm moving this data from D13003 to D3358, and then I'm byte swapping it, and I'm changing that data around so it is usable data. After the byte swap, then I'll move both those from D3357 into D3360. So that takes a double word or 4 bytes of data, and I'm putting those together to make that distance value. Now, if I open up my HMI screen, I can go to my screen DT80 that I've already created, and you see the D3360. D3360 correlates with the D3360 that I have here. Now, once I open that up, you can see I am pulling from the Omron PLC from D3360. And the format that I have is a 32-bit unsigned. And I've already got my decimal point in there since I will be going down to 1/10 of a millimeter. Now, just to show the operation of the DT80 and the PLC program, I'll do a quick simulation. Now, as I move my hand farther or closer away, you can see that these numbers correspond what's on the DT80 itself. So right now the DT80 is reading 2.381 meters, and that's exactly what I have here as well. Let me know if you have any questions, and I hope this helps.